This video will go through using desmos to do a quick check to check that your shortcut rule work to find the derivative is actually correct. So I have an example here of a function f of x, which I've defined in desmos, and I've shown the graph to the right. If you were asked to find the derivative of f of x, hopefully you recognize that you need to use the product rule. So I'm going to define that derivative using the product rule. I'm going to call it d of x here. Remember, you cannot in Desmos define a function as f prime of x. That's going to be that's a pre-built function in Desmos. You can't redefine a function as f prime of x in Desmos. You have to call it something else like d of x. I'm going to define it incorrectly. I'm going to forget to use the product rule. So I'm going to say, all right, the derivative is 10 times e to the negative 0.03x. And how about I forget to use the chain rule too? Okay. Let's say that's how I defined the derivative incorrectly. There it is. It's displaying that graph. I'm going to maybe change the color of it to blue. Okay, so my incorrect derivative there is in blue. And then I can ask Desmos to display for me f prime of x. Desmos has a pre-built function called f prime of x. I'm going to make this one green just so we can differentiate. And I can immediately see that the actual derivative graph in green is different than the derivative that I defined in there, which is in blue. So I know I did something wrong when I used the shortcut rules. So now I could go up here and say, oh, okay, right, I forgot that I have to use the product rule. So let me this time go ahead and use the product rule correctly. So the derivative of 10x is 10 times the original second function, e to the negative 0.03x, plus the original first function, 10x, times, I need to find the derivative of e to the negative 0.03x, so that would be e to the negative 0.03x, and don't forget the chain rule, we got to multiply by the derivative of that negative 0.03x, so I'd multiply by negative 0.03. And notice, as soon as d of x is defined correctly, it is now exactly overlaying the function f prime of x. Let me turn it off for a second. You see there's green, f prime of x. I'm going to turn back d of x. Now the blue overlays f prime of x. Now this is not a proof that these two things are equivalent. I have not proven that d of x is equal to f prime of x. However, it is a great way to just quickly check that it seems correct. So when you're doing your shortcut rules work, if you want to do a quick check and see if your defined derivative with your shortcut rules is accurate, this is a great way to just quickly check and see.